This is IAT814 Visual Analytics, Lecture 4.2. In this lecture segment, we are going to talk about visualization tasks 6 through 10 from Amar and Stasko's Visualization Basic Tasks list. This builds on Lecture 4.1, which explained where the task list came from and who built it, and Lecture 4.1 introduced tasks 1 through 5. The next task is to determine range, and the general description there is to, given a set of data cases and an attribute of interest, find the span of values within the set. So, for example, what is the range of film lengths? What is the range of car horsepowers? What actresses are in the data set? That third query there is not a numerical range that we're looking for. That's more or less kind of an alphabetical query. The thing that we're going to do now is what is the range of incomes in the state. And what we're going to do now is once again go back to Tableau, and I've gotten rid of the box plots, and now what I'm going to do is I'm going to drop the college degree data into the filter. And one of the things that doing so enables us to do is to participate in this dialogue. I'm just going to go to next, and what I do is I get a report of the range, and I can use that to create a filter. And so this is an additional filter. Let's just have that to be, let's do round figures here. Let's be that from 0.25 to 35. We apply that, and then we get, let's press OK and be done with it, and then we get a different subset of the states. In the range is 25 to 35. But part of the thing that I was intending to do there, let me now get rid of that, is to determine the range. And I can determine the range within Tableau, given a scatter plotted plot, by hovering on what looks like the lowest percentage of college degrees, and hovering above the highest, and hovering above the highest income and the lowest income. And so Tableau gives us multiple ways of doing that. The purpose of showing the dialogue is it'll tell you the numeric range and reasonably high resolution information about what the range is. For a single dimension at a time. In a scatter plot, you can query 2 dimensions at a time. If you have other plot styles, you can also use the tooltips to tell you some more information. So now that we've determined the range, let's now go to task 7, which is characterize distribution. And what that is given a set of data cases and a quantitative attribute of interest, characterize the distribution of that attribute value over the set. So for example, what's the distribution of carbohydrates in cereals, in breakfast cereals? What's the age distribution of shoppers? And in our case, what is the distribution of college degrees? Now I'm just showing single dimensions here in these questions, and I'm going to do that now in Tableau. So just hold on. And here we go. Here's Tableau once again. And what I'm going to do now is drop all this stuff out of the Tableau's display. And I'm going to drag the college degree thing into columns. No, that was me trying to rename it. That's not what I wanted to do. Okay, come on. There we go. And doing that starts a part of the dialogue, and what I would like to do is, in this show me dialogue, it gives you a choice of visualizations, the bar chart, etc. And what I'm going to do is I'm going to choose histogram. One of the things that can be challenging with respect to the use of Tableau is that sometimes what you want to see, and what you have to do is you have to set Tableau up to automatically present you the option of doing this. And so that's why I was getting rid of variables, so that it would have a single dimension. It says to get a histogram down below, try one measure. So I dragged a measure into the columns slot, And now I'm going to select this. And so here we have a plot of all, and let me get rid of the show me dialog, a plot of a histogram of all the states. And I'm going to put labels on. And in putting labels on, I also get little dividing lines indicating the size of these cells. You'll notice the size of these cells is 1 unit each. And many of the cells are labeled. Not all of the cells are labeled, just simply because there's not enough space. So this thing for New Mexico, there's not enough room to print New Mexico on a single line, so they just don't do it. So anyway, this gives you an indication of the distribution of college degree values, ranging from a low of from 20 up to 42%. And West Virginia is included in this slot because it rounds to 0.2. And the histogram's been created automatically by Tableau, and the bins it created are the size 0.2. 2 percentage points, so 0.20, 0.22, 24, etc., all the way up to 0.44. One other thing that I wanted to mention, that this distribution that you see here is kind of sort of normal. It isn't quite. There's perhaps a bit of skewness. It's perhaps positively skewed because there's higher quantities of stuff to the right of the mode than there is to the left. But it's close to normal with a bit of skew. And what I'd like to do now is I'm going to drag the median income thing into the rows, and I'm going to get two different histograms. I'm going to delete the count thing. I'm going to remove it from this list. And now I get a similar looking histogram, but it's not identical. And the reason why it's not identical is that whereas in the count one, it was treating each individual data item as the same size, what it's doing in the vertical dimension now is stacking up things according to the median income size. So it's adding incomes here. So this is Virginia plus New Jersey plus Maryland plus Connecticut added up. And that might make some sense if you have a quantitative value in which it makes sense to sum things up, say in a sales plot, but that's not quite the case here. So I'm just simply showing you that sometimes you need to make sure, particularly with Tableau, if you get something that looks like a histogram, just make sure to pay attention to if there's additional things that Tableau wants to give you, that making sure it makes sense for the kinds of questions that you want to ask while using Tableau. Okay, so now let's get back to the slides, and we're going to get to the next thing, which is, given that you've got a distribution, what you'd often want to do is to find anomalies. So what does find anomalies mean? We mentioned that in the stats lecture series, but the general description is identify any anomalies within a given set of data cases with respect to given relationship or expectation. For example, statistical outliers. So examples are there any cereals that have high calories but low sugar? I doubt it. And are there exceptions to the trend of higher levels of college begetting higher median income? So let's once again go back to Tableau, take a look at that display. And what I'm going to do now is I am going to hopefully quickly change the ranges such that this scatter plot, which at the moment is based at 0, I'm going to not include 0 and change that to fixed, and change that to 0.45 and change that to 0.15. And the purpose of me doing this is to change the range, the plotted range in the scene. And so I'm going to do the same over here, going from turning off that, go to fixed, go from 40,000 to, for the sake of argument, 90,000, just to keep round figures. Go away. And now the scatter plot takes more space on the plotting area because the range of stuff to the left of 19.9% college degrees and below 40K, I've just simply, that's off below and to the left. And so it makes it a little bit easier to see if there's, exceptions to some degree to the way in which the relationship, which seems to be, pretty strong between the college degrees and median income is. And you can see that on the positive side that Alaska and Hawaii and California have fairly high incomes, but not so high college degree percentages, and Vermont is an exception in the opposite direction, higher degree of education, but not necessarily a higher median income. So anyway, that's an example of discovering an anomaly. And to kind of reinforce that, I'm going to put a trend line in here. And this is what I'm going to do is just choose the linear Pearson's correlation coefficient, drop that in there. And so there's the trend line, or the linear Pearson's correlation. And we can see that's the line. You can also see that it's a pretty good correlation R squared number with 0.72. And, so you can see a pretty good relationship. And the purpose of me putting this in is to enable you to see the anomalies a little bit more clearly. So let's go to the slides and go on to the next item. And the next item, I'm going to use a different data set for this one. But the idea is essentially is that given a set of data cases, find clusters of similar attribute values. For example, are there groups of cereals with similar fat / calories / sugar? Are all comedies of the same length? Is there a cluster of a particular kind? And what the question I'm now going to ask that with a Tableau demo is, what measures of irises from the iris dataset are reliable species indicators? So the iris dataset is a dataset in which let me go there before I continue talking. In the iris dataset, this is a data collection that plots the characteristics of irises on the Gaspé Peninsula, and this data was collected in the 1930s. The idea of the dataset was to use the physical characteristics of the flowers, irises, to be able to understand something about the way in which the species worked. So let me just make that a little bit bigger. And so here is a plot of 2 of the 4 data fields of the irises, and that's sepal width and sepal length. There is also petal length and petal width. And when we do that, we get a very simple scatter plot array in which sepal width, this is a common dimension here, and that's plotted against sepal length, as we said before. So that was the one we started with. This is sepal width plotted against petal length, and this is petal width against petal length. So this is petal versus petal, and this is sepal versus sepal. In any case, you can see that there are, depending on which dimensions you plot against which other dimensions, there's a pair of clusters here, and a corresponding pair of clusters here, pair of clusters here. These all correspond to each other, and there's some similarity, kind of sort of clusters here, but it's not so obvious when you're comparing sepal length and sepal width. So what I'm going to do next is go to the Analytics tab again, and there's another thing that we can do called cluster. And so this is an automatic operation that Tableau can do for you. Press on it, drag it into the scene, and it gives you the opportunity to create clusters. And so what I'm going to do is do that. And what it's clustering on is those are the data dimensions that it's going to use for its clustering algorithm. And it's going to find automatically the number of clusters that there are. This 5 thing is an indicator of the number of times I've attempted to find clusters. So I've been doing this behind the scenes, and I've done it 4 more times previously. So let me just get rid of that. And what it's done is identified 2 clusters. the yellow one, and the blue one. And you can see clearly there's the blues. These are all the data cases that belong to one cluster, and the yellow the yellow circles are the ones that belong to the other cluster. So in order to really answer the question that we had earlier, what I'm going to do is I'm going to go back to the data case, and there is an alphabetical field, an alphabetical variable, and what I'm going to do is I'm going to drag that onto glyph size, show that, put that there, and the class label over here is saying that the species Iris setosa is now being applied to small circles. That's the yellow ones, and the large circles are Iris versicolor. And you can see that there's a clear distinction between the two species and the physical characteristics. One of the things that's a little bit difficult is if I now get rid of petal length and petal width out of this plot, is that the two clusters that I show here, there's the thing that makes clustering hard is many of the clustering algorithms, which we'll talk about later on in the term, rely on a normal distribution. And in this case, that's kind of not how the shape of those collections of data items looks. Okay, let's go back to the slides. So the general description is to, what measures of irises are reliable species indicators. In this case, I intentionally chose sepal length and width to indicate that if you just use those as measures, it probably wouldn't work well because the shapes of the things, the plot of those two variables leads to a collection of data points that very closely almost overlap each other, so they're not so reliable or so easy to find. The last item in our list of 10 tasks is to correlate, and once again we're going to go back to the Tableau and to this income versus education thing, but the general description is: given a set of data cases and two attributes, determine useful relationships between the values of those attributes. And we've been staring at this college education thing for a while now, so it's pretty clear what the relationship is. Other example questions are: is there a correlation between carbohydrates and fat? Is there a correlation between country of origin of cars and miles per gallon? In the 70s, I think there was, and that cars data set goes from 1970 to 1982. And finally on this list, what's the relationship between college and income? Let's now go to Tableau. I still have the trend line from the previous discussion, and you can see that there is a relationship. You can also see what the quality of that relationship is. The R-squared value, which is indicative of the quality of the correlation, is 0.72, which is a reasonably strong correlation. Let me go to analytics once again, and I'm going to drag in a trend line. What Tableau does is it gives you the options of the kinds of trend lines that you can draw. And instead of linear, which is what this thing is, I'm going to now do power. And what it does is it replaces the previous trend line with the power trend line, and it's giving you the formula that it computed. And one of the reasons why I chose this one, I selected each of the others, is that the R-squared value is a little bit higher at 0.74. But it's a very subtle difference between that and the linear one, and unfortunately I cannot show both. In any case, this trend line, it does indicate that there's a strong correlation there. And it might be that the relationship isn't linear, that there's something a little bit more interesting going on. So that concludes IAT814 Lecture 4.2, which has been about visualization tasks 6 through 10. My goal here was to break the task list into two parts so that they can be easily accessible as reasonable-sized videos.